Hello, everyone. Thank you so much for being with us in the first episode. In the first episode, we look at how best we can find limit of functions if they exist using numerical methods. In this second episode, we are going to learn how we can develop and use the limit principles to calculate limits. And I would want you to take your time to understand the concept so that we can use to solve problems. Thank you. Just like in every game, there are rules that govern it. It's the same with limits. Limit is in as much as it look quite simple. There are rules that governs it. There are rules that govern it. So we have to learn the rules or the principles that govern limits. So at this point, I want us to embrace the concept even as we delve deeper into it. All right, so let's start. So is the constant. The first rule is that if C is any constant, so we claim that if C is any constant, then the limit that constant as x approaches a is C. So we claim that if C is any constant, then we claim that the limit of that constant as x approaches a is the constant. This is a very interesting, principle or law. So I want us to have it in mind because we'll be using them to solve problems. All right. So the second problem that I want us to also look at it, which is also very important, is it has to do with the power function. Okay, so the law 2, any positive integer n, we claim that the limit of that power function as x approaches is the limit of the base raised to that power. So the limit of the power function is the limit of the base raised to that power. I hope we are okay. We will solve more examples, then you would understand it better. So at this point, what I want us to do is to try to learn the laws, and we'll use the laws to solve problems. It's just like in every society, there are laws that govern that particular society. It's the same with limit. So we have to try our best possible to understand the laws or the principles so that we don't find ourselves in trouble. The same thing here. So let's go. Under the same law, we can, rewrite this in a different form. So this, which is the same thing, is also the power function, okay? So it's just going to be the limit of the base raised to that power. So we're just switching the limit. Hope this is okay. Good. So with the third law, we claim that the limit, either the sum or the difference of two functions as x approaches a is just the what? It's just the sum or the difference of the limit, okay? It's just the sum or difference of the limit. It's more or less so we can distribute the limit of each function. I believe this is very simple, right? Good. All right. So let's look at it. The fourth law says that the limit of a product is a product of the limit. This is very interesting also. So the limit of a product, so the limit of the product of two functions is the product of the limit. Okay, very good. The limit of the product of two functions is a product of the limit, So I want us to bear that in mind. Right. The last but one law that I want us to consider is, so we claim that the limit of a quotient is the quotient of the limit. What am I trying to say? So given two functions, we claim that the limit of the quotient, the limit of their quotient is just what? The quotient of the limit. It's just the quotient of the limit. I believe we are all getting it. Don't worry. I know the rules are many, but we'll take our time, then we go through them one after the other as we begin to solve more examples. And I believe you understand them, better. So I want us to take note. I think for today, the last law that I want us to look at is the limit of a constant times a function. So if you have the limit of a function, if I multiply it by any constant, what is the result? How does it look like? And that's what I want us to look at. And that is going to be the last law for the day. So we claim that the limit of a constant function, so the limit of a constant times a function, is just going to be the constant times the limit, okay? Just going to be the constant times the limit, right? So right now we've been able to learn, 6 laws. The first law is that given any constant, then the limit of that constant is a constant, right? And the second law is that for any positive integer n, then given any power function, we claim that the limit of the power function, okay, the limit of a constant times the function is the constant times the limit of that function, right? At this point, I want to solve examples. So we are going to look at examples. So example 1. So if I give you the limit, if I ask you to evaluate the limit of the function x squared minus 3x plus 7. As x approaches 4, what do we do? Which law can we use to solve this problem? Which law? Anyone? So we can use the limit of the sum of the difference. Very good. That's good. So we said the difference of the limit, right? In which case, over here, we can do the distribution. We can distribute, okay? So now let's do distribution. So which means we can distribution, we mean limit as x approaches 4 of the function x squared, and limit of the function 3x as x approaches 4 plus limit of the constant 7 as x approaches 4. Now, over here, what's the limit of the function x squared as x approaches 4, right? So which means that wherever we see x, we should just replace it by 4, in which case we're going to have 4 to the power 2 minus. Then over here, it is the same as this, which means wherever you see x, you should replace it by 4. And we learned that the limit of a constant, the limit of any constant is the constant. So the limit of the constant 7 is what? 7. Good. So in which case, we're going to have what? 16 minus 12 plus 7. And that is, what is the value? Which is 11, right? Good, good. You guys are very good. I like that. So with example 2, if I ask you to evaluate the cube root of x to the power 3 plus 1 as x approaches 1, what do we get? Which law can we use to apply to this? So it's a law that relates to power function, and we claim that is the limit of the what? Base raised to the power, right? Very good. So what it means is that we can just switch in the limit, right? Now, well, it means that wherever you see x, if you replace it by 1, in which case we're going to have what? 1 to the power 3 plus 1. And that gives us what? So you're going to have the cube root. You're going to have the cube root of 2. Very good. You guys are very good. So I believe that's beginning to be able to with the concept. Now, one more example that I wanted to solve, that will be the last example under the laws, the quotient. How do we apply the quotient rule? So if I give you a problem like this to evaluate, so limit as x approaches x squared plus 1 all divided by x. If I give you this problem to solve, what do we get? Now, we learned a law that has to do with quotient, because the function we are looking at is a quotient problem, right? It's a quotient function, right? All right. So in that case, we have to apply the limit law that sort of relate to quotient. And we claim that the limit of a quotient of the function x as x approaches 2. That gives us what? 5 out of 2. So this becomes the limit value. At this point, if you have any questions, please put it in the comment section, and I would reply to you guys. So let's take a break. We'll come back. Thank you.